This blue box might not look like much, but it's actually part of a rocket propulsion system for small satellites. And as dubious as that might sound at first, this piece of plastic is going to help keep space clean. These are models of small satellites called CubeSats, which are standardized satellites made in 10-centimeter cube multiples, like this. Each of these satellites is a student project or commercial endeavor designed to increase our understanding of Earth and space beyond. The actual missions that these satellites conduct vary. A bunch of them can take the place of a single, big, expensive satellite to take pictures, make measurements, or provide communication. Every satellite launched provides us with information that can help us make the next generation of satellites even better. CubeSats are gaining in popularity in large part because they're cheap and simple to build. As a result, hundreds of these CubeSats have been launched into space and are orbiting Earth right now as they work towards completing important missions. More are being launched every year. The problem is that CubeSats are so small that they don't have room for a conventional propulsion system. So after their missions are complete and they're no longer in contact with Earth, they remain in space as space junk. It's been estimated that over 750,000 man-made objects bigger than 1 centimeter are currently in orbit. And while a few hundred CubeSats sounds like a really small part of that, they still have the potential to cause major problems. Without a good propulsion system, CubeSats have no way to move around in space quickly. So if they're heading towards a big, expensive satellite, like the International Space Station, it's the big satellite that has to move out of the way. And this can cause problems for the astronauts on board and even be a safety issue. When collisions do happen, they produce even more space debris, which produce even more collisions. With every new CubeSat launched, the risk of these collisions that they can produce rises exponentially. Satellite launches have already been delayed just to avoid predicted collisions. If the debris gets bad enough, we won't be able to launch anything from Earth at all because the risk of running into something on the way up to space will be too high, especially for manned missions. I, for one, don't want to be stuck here on Earth. There's still too much left in the universe to explore. I want to be able to see Mars one day, and ideally not get stuck there either, like Matt Damon in The Martian. I've always been entranced by the stars and the idea of other worlds out in the universe. I spend a lot of time reading science fiction novels like Ender's Game, watching Ancient Aliens, and waiting for my chance to travel to magical galaxies far, far away. The day I learned that space travel isn't, unfortunately, all magic and romance, I was reading a magazine as I waited for some appointment. It described all the garbage orbiting Earth in an infographic, and I then became suddenly and uncomfortably aware that space isn't as perfectly pristine and open for space tourism as I thought. Junkie space stuck in the back of my mind for years, until I learned that a new special topics class was being offered here at USU on space debris. When the professor allowed us to pick our topic for the final project, I knew that this was what I had studied so hard as an undergraduate to do. I was going to use rockets to help clean up space. I started working with rockets as a freshman. I helped make and test hybrid rockets, which combine a solid fuel with a liquid oxidizer to create thrust. Over the years, we started 3D printing our hybrid rockets out of ABS plastic, which is the same plastic that Legos are made out of. And when I say the fuel is made out of plastic, I mean it. We're actually burning the plastic itself. And because the rockets are made out of such common plastic, they're safe to handle with bare hands, they're cheap to make, and we can print them into virtually any size and shape that we want. These properties make hybrid rockets ideal for use in a CubeSat. Putting rockets on a CubeSat will give the spacecraft enough thrust to travel out of space and into Earth's atmosphere, will burn up into oblivion and won't be able to produce any more future collisions. This capability will allow CubeSats to launches to continue far into the future while alleviating the concerns out there that these CubeSats are contributing to the debris problem. My job is to figure out how to resize the USU hybrid rockets to fit inside one of these tiny CubeSats. I'm working to figure out the right combination of plastic fuel and gaseous oxygen to allow the CubeSats to quickly move large distances in space, a capability that does not currently exist. I've already designed the optimal fuel geometry, the nozzle shape, the plumbing required to get the oxygen to the fuel, and the ignition system that will light the whole thing on fire. The first test will be on a single rocket motor, just so I can check that everything is going to perform as I expect. The final system will have 4 rockets, so it can have 4 times the thrust. I'll perform initial testing here at USU, and I'll be in Alabama at NASA Marshall Space Flight Center this summer, so I can test my system in a vacuum chamber that mimics some of the conditions in space. This will help me determine how effective my system will actually be at removing these CubeSats from orbit. Space debris is a big problem, one that people around the world are working to solve. I'm contributing one very small part of this in the form of rockets for CubeSats, because space still has so much to offer us. And I want to continue being able to study and explore space unimpeded by debris. Thank you.